it's Miss Farmer. Alright, so this recording is for my 9 and 10 o'clock class, who I, unfortunately, because my computer decided to update, could not teach this to you today. And I know you guys went through your OLS, which is awesome, but I wanted to make sure I send you a recording of what I was going to teach you today anyway. So, we are still doing the same standard. It's just a super big standard. And we're going to talk about polynomials. We're going to talk about factoring today. So before, you have always had two binomials. So you've always been given kind of, that's not drawing. You've always been given like two binomials, and then you FOILed it and distributed, and then you got, like x squared plus 3x minus 9. We are going to go backwards today, and I'm going to show you if I give you a polynomial, which today is only going to be a binomial. If I give you a binomial, can you get back to this form with two other binomials, two factors? So your bell work was going to be to watch this video, and if you don't have, obviously you can't watch the video in the bell work, but if you go to today, which is 2.10, difference of squares, and you click on more in the class plan, it is right here. So this is a super helpful video for you. I obviously won't have 10 and 9 and 10 recordings. 12 recording will be up here soon. I would highly suggest you go through the 2.10 factor perfect squares as well, or here's a Khan Academy link for practicing perfect square or difference of squares. Sure, let's go back to the PowerPoint. All right, so I know I flipped it around. I've been telling you guys that I was going to do 2.9 today, but I switched it. I wanted to do 2.10 just because I wanted to. You do not have anything that's graded for homework, but you have an extra credit opportunity, which is your polynomials quiz. It's a practice quiz to help you prepare for tomorrow. All right, so let's talk about the difference of squares. So in order to use this method, which this is a method to factor, difference of squares is just a method you use, you have to have certain qualifications. So you have to have only two terms, which is a binomial. The first term has to be a perfect square. And if you're wondering again, remember what a perfect square is. That is something that if it's square rooted can be like a pretty number. So for example, if I choose the number 9 and I square root it, it's 3 times 3. That's a perfect square. 16 is 4 times 4. 25 is 5 times 5. X squared is x times x. Y squared is y times y. It has to be a perfect square. The last term, or the second term, has to also be a perfect square. And this is the big key here. There has to be a subtraction problem. It has to be subtraction. Otherwise, we can't use the word difference of squares. If all of these terms are met, then we can go ahead and factor this. So let's look at an example. So right here, I told you to factor x squared minus 25. Please ignore this factoring table thing. I have no idea why that's in there. It's just, yeah, okay. So first thing you have to ask yourself is, do you have a GCF, which is greatest common factor, which is what we did yesterday? Because sometimes you need to take out the GCF in order to get a perfect square. So there's no GCF. There's no number that I can divide into both of these. There's no variable I can divide out. So they don't have a GCF. All right. Are there only two terms? Yep. X squared is a term and 25 is a term. Is the first term a perfect square? Yes. X squared can be brought down into x times x. Is the second term a perfect square? Yep. 25 can be brought down into 5 times 5. And is there a subtraction? Yes. It has to have subtraction. I told you how important that is. If there is subtraction, that means that this is a negative 25, and these have to be opposite signs because you can't do two positives. That's not going to multiply to give you a negative. So one gets a plus sign, one gets a minus sign. It does not matter which one gets which. It doesn't matter. So if you were to go ahead and FOIL this out, if you were to, do like first and then outer and then inner and then last and simplify, you're going to get this guy. You're going to get this top answer. We're just going backwards. It's like I'm giving you the answer and you tell me what the two binomials that multiplied it to make that. All right, let's look at another one. This one, a little bit different. It has a number in front of x. Do you have a GCF? 16 and 9. There is no number that I can divide into both of those, and there's no variable that they both have in common. So it doesn't have a GCF. Two terms? Yep. First one's a perfect square. 16 and x both have to be perfect squares, and they are. 16 can break down into 4 times 4. X squared can be broken down to x times x. And I'm going to keep the 4x together because the 16 and x squared are together up here. And then 9 is, is the second term a perfect square? Absolutely. 9 can be broken down into 3 times 3. And is there subtraction? Yep. So that's why one gets a plus sign, one gets a minus sign, because this is technically negative 9. This is just another example. 81 is a perfect square. So 81 breaks into 9 and 9. A squared, A and A. 49, 7 and 7. And B squared. And this is all in the notes that I'm going to attach to this email, as well as they're going to be in the class plan. So I'm going to show you some examples. So let's go ahead and do this. This box up here is to remind you that once you break it down into two parentheses, I don't care which one gets the subtraction sign. It doesn't matter. The first one can get it or the second one. All right, so let's look at number 1. Do you have a GCF? Well, they don't have a number I can divide out, and they don't have a variable, so no, I don't have a GCF. So this is as good as it's going to get. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Is there a subtraction? Yes. All right, cool. Let's go ahead and factor using this method. And how we do that is we make two parentheses, because I'm trying to make two binomials. X breaks down into x times x. 25 breaks down into 5 times 5. And then one gets a plus sign, one gets a minus sign. That's it. That's your answer. So let's do the second one. This guy. Do you have a GCF? Well, at first when I looked at this, I was like, all right, 75 is not a perfect square, and neither is 12. But maybe because they're not as simplified as possible, because there is a number that goes into both, and that number is 3. So if I take 3 out, 75 divided by 3 is 25, and 12 divided by 3 is 4. Oh, there we go. 25 and 4 are both perfect squares, so let's go ahead and do this. So my 3 still stays, and I'm going to do 2 new parentheses. 25 breaks down into 5 times 5. X squared is x times x. And 4 is 2 times 2. And then doesn't matter which one gets a minus sign, as long as one of them does. Not so bad. It's pretty easy. The process itself is not hard. The difficult part is recognizing if it is a perfect square, or if you can even use difference of squares. So let's try that. So this one, if I were to factor this, I have to ask myself, the first one is a perfect square, the second one's a perfect square, and there's a minus sign. Cool, I can use this method. So when I do that, x squared gets broken down into x times x, and y squared gets broken down into y times y. I told you again, who gets the plus sign and who gets the minus sign does not matter. So in this instance, both 2 and 3 are right. They're both right because it doesn't matter if you put the plus sign in the first parenthesis or the second one, as long as you know that they both can't be the same. So they both can't be plus signs, they both can't be minus signs. This is another example. So when you look at this, you're like, okay, the first thing you ask yourself is, does it have a GCF? It does. We can take out 2, and this turns into 8c squared plus 4d squared. And then you sit there going, okay, well, is the first one a perfect square? Yes. No, I'm sorry, that should be a 9. Sorry. Erase that. It should be a 9. I apologize. So is the first one a perfect square? Yes, 9 is a perfect square, so is 4. So this works out. So at first you think, absolutely, I can go ahead and do this, but then you forget about the very last part of it. And is there a subtraction sign? There is not. If there is no subtraction sign, it's called prime, but it just means that you cannot use the difference of squares method. That's all it means, is you can't use this method. Not that it can't be factored, but you can't use the method. So some examples here are determine whether it's a difference of squares at all, and then if so, break it down. Okay, so the first box, is this a difference of squares? The first thing I notice is that's a plus sign. It's a no. That's a super big no. Because difference means subtract. If I tell you the difference between two numbers, I'm telling you to subtract them. So let's do this one. Is there a difference of squares here? Well, we have a subtraction sign. This is a perfect square. This is a perfect square. Yep, it looks good. And I can go ahead and break it down into 2 parentheses. X turns into x times x. 49 is 7 times 7. And then I don't care who gets the plus sign, but one of them's got to get it. All right, example 3. X squared, that's a perfect square. 9's a perfect square. My GCF's taken out, and I got a subtraction sign. Absolutely, I can do this. X squared is just x times x. 9 squared is 3 times 3. And I don't care who gets the plus sign. All right, so let's do this one. Oh, it's a big number. We can handle it, though. We have a subtraction sign. X squared is a perfect square, so is 625. This is actually 25 times 25. And if you didn't know, you just take your calculator out and you do square root of 625. So this one will work. X squared breaks down into x and x. 625 breaks down into 25 times 25. And then I don't care who gets the plus sign. This one is a difference of 2 squares. Got a minus sign going on. Beautiful. X squared is a perfect square. Oh, hold on. There's no number that I can multiply by itself to be 8. So that's a big fat no. Can't do that. I can't use this method. The last one, I'm just going to go ahead and do it for you. It is x squared is x times x. 1 is 1 times 1. Don't care who gets the plus sign. This is pretty easy. So what we did for the rest of class is we did some examples, and I'll go through 1 or 2 of them with you, but I don't want this recording to be too long because you missed, I don't want you to try to watch this recording on top of everything. So let's do practice problem 1. So we have a subtraction problem, doing great here. Then 9 is a perfect square, x squared is a perfect square, and 1 is a perfect square. Woohoo! This is beautiful. So let's go ahead and do 2 parentheses. 9 breaks down into 3 times 3. X squared breaks down into x times x. 1 breaks down into 1 times 1. And one of them gets a plus sign, one of them gets a minus sign. Doesn't matter which one. This is getting pretty easy, huh? All right. So let's do this one. pick a whole different color. Do purple. Okay, so when I first looked at this one, I'm like, oh, subtraction problem, we're doing great, x squared, but wait a